Okay, very cool. Let's start. We start today from another question from my side. So this is our infrastructure. But can you tell me this? What will happen when we have a load balancer and two instances when, for example, this instance for some reason became unusable, goes away?
So it will fail. We should have an auto scaling policy to create
no need to hurry with that.
Okay.
You're giving answer even before, right?
Okay.
Exactly in this case, when we have a load balancer and one of the instances goes away, what will happen?
The traffic will only go to the only available instance, so the load balancer will only forward to the only active instance.
Yes, that's correct. And what if accidentally we will, for example, terminate this one as well?
We lose access to our application.
Yes, that is right. And here's exactly what Mohammed skipped. And what I wanted to point out is we cannot afford having static instances just deployed as EC2 instances, right? We need capability to auto-heal them, and if needed, also scale them and add even more instances to handle requests, to handle traffic automatically without having to jump in with some manual actions. And this is exactly what we will do today. And there is a feature for that, as correctly Mohammed told. This feature is called auto-scaling groups, and this is what we will configure. But before we do so, let me open the browser and basically repeat the same that we have, but on real practice, just demonstrate that our assumptions were right. So here is my web application, and in a second I will log into AWS portal and terminate my instances one by one. All right. So I have 3 instances running. I will terminate the first one. Then let's double check. Oh, it already broke. 1 second. Probably renew the session. Let me try the incognito mode. 1 second. Yes. Incognito, it was right. Most likely browser was caching and still redirecting me to the previous node in the load balancer. And when I go and terminate the remaining one, when we refresh, it gives us bait gateway. And 502 bait gateway means exactly this, that we have a gateway. That's our load balancer. And behind this gateway, there is nothing that can serve the request. Every time you see 502, most likely there will be a load balancer. Most likely there will be something wrong behind this load balancer. And what we'll do next is open our code and configure some auto-scaling groups. And in the meantime, let me know if you have any questions. Okay, then let's move forward and configure our auto-scaling. We have a separate file for that. Let's call it ASG. And first resource that we need to create is called AWS Launch Configuration. AWS Launch Configuration is a template that is used by auto-scaling group that defines things like ID of our image, instance type, or for example, key name. You can think of it like an AMI. For instance, one AMI can create multiple instances. Same for launch configuration. Single launch configuration can create multiple instances within auto-scaling group. So where you have auto-scaling group, you always should declare launch configuration or modern version launch template before you proceed to the auto-scaling group itself. For image ID, we can pick our data source. It's identical to EC2. Instance type, same as in our infrastructure. Key name, the name of our key. Also, user data. And also security group, also declared here. Okay, very cool. We've created our launch configuration. Now we create the auto-scaling group that creates our instances themselves. Can anyone guess what these three parameters mean? Yes.
It specifies the minimum of like at all time we should have at least 2 AWS instances running, and like at maximum we can scale maximum up to 4. Nothing more than 4.
Yeah, very good answer. But let me ask further. What number of instances will it create when we run Terraform apply? 2. Yes.
2. Because it's desired.
Yeah, desired. And what's the point in minimum and desired? Do you have any ideas?
So it can be the desired is 3 and the minimum is 2. And
yeah, and what's the point in desired? Any ideas?
desired is the optimal number of instances.
Yes, kind of. So everyone had the guess. Everyone was sort of right, but let me explain further. So in like additional optional home task, I will ask you not only to create this auto-scaling group, but also to actually make it scale automatically. So what it means? It means you'll need to pick up some metric, for example, CPU utilization. And if CPU utilization is high, you'll need to automatically, using auto-scaling group, increase the number of instances. If it's low, you need to decrease the number of instances, right? This means, for example, during weekdays when traffic is high, we use required number of compute to make services running. But at weekends, for example, we don't have to spend unused capacity and scale it down. But now what is happening? This desired capacity is the actual number of instances that needs to be deployed right now. It should be between minimum and maximum. But if I, for example, change it to 3, it will deploy 3. If I change it to 4, it will deploy 4. And desired capacity is the actual number, actual amount of instances that we'll have. And what, for example, CloudWatch will do is it will exactly change this value of desired capacity. This means there might be different types of automation, that scaling up and scaling down, but at the end of the day, all of them are manipulating this parameter, this desired capacity. Does it make sense?
Yes.
Yes.
Okay, and we will automatically configure these auto-scaling groups so that all instances are added to our load balancer without us having to manually configure or manually add each and every instance to the target group that we'll have. We will obviously reference our launch configuration. So basically, here's the connection. We create auto-scaling group, it creates 2 instances, and regarding all the parameters like name, prefix, user data, and key name, everything related to each particular instance, it will just check which launch configuration it is using and pick all these options from here. And last but not least, almost last but not least, there is one more VPC zone identifier. Essentially, it's our private subnet ID. But in our case, it's private subnet IDs. Let me real quick double check one thing in documentation. Hold on a second. Yes, it should be a list of private subnets. That's right. Okay. Okay, and also what we'll do is we'll remove our private instances. We no longer need them. And we'll remove our target group attachment. We'll no longer need them because all instances that we spin up will be deployed automatically and using auto-scaling group and connected automatically to our load balancer through this property. We'll automatically put all our instances into the target group. Let's try running Terraform apply. Hopefully I did not make any stupid misprints.
The subnet you have, the public subnet, isn't it supposed to be the private?
This is very good.
Yeah.
Yeah, very good take. Thank you very much. Of course, it should be private. Okay, it created, and let's go to our instances. I think we have something, but the question is why they are not tagged, right? We probably need to add the name tag as well. Same thing we usually do. So it will be one second. Let's run Terraform apply, and there will be okay. Yeah, let me check how we usually do tags. Let's say VPC tags equal.
You should add it to the configuration, no?
What do you mean?
Like the AWS launch configuration, maybe?
No.
Oh.
That each resource can be tagged. Yeah, I wanted to show you one trick, but it's no longer working in the latest versions of Terraform. So, anyways, then let me. This syntax is correct, but for everything but autoscaling group. Instead, we need to use slightly different syntax like this. So, and the idea is that it's not only tagging this autoscaling group itself and launch autoscaling group itself, but also all instances that will be that will be spawned by this autoscaling group. Let me run it again. But when we get back to our instances, we still see that they don't have this tag. Why? Because autoscaling group propagates them directly at launch. So if we, for example, terminate an instance, we'll need to wait a couple minutes to allow autoscaling to discover this and create, and let's immediately terminate the second one as well. Autoscaling will immediately discover this and make the adjustments. Already, you can see there is one more instance automatically created. I did not do anything, and it spawned. Let's go and check autoscaling groups and see how it looks from inside. Here it is. It says desired capacity, minimum, maximum, 3. Why 3? Well, let's check. Go to instances. It says unhealthy, right? Because it's terminating now. It takes time for it to process this. And as soon as it discovered that the instance actually terminated from outside, it will remove these terminating instances, this terminating instance. And we can edit this, for example, and adjust our desired capacity. Let's say 6 instances we would like. We will also increase maximum. Press update. It's saying updating capacity. And probably it will also require a couple minutes to deploy these additional extra 6, actually 4 additional instances. So we have total of 6. Can we see them in instances? Right, here they are. 1, 2, 3, 4. 1, 2, 3, 4, 5. That's exactly as we expected. And obviously our endpoint, our game continues to operate. Doesn't matter how many instances we have. That's for the load balancers. Let's create new branch. Okay, very good. And in the meantime, I will reduce our auto-scaling group back to 2 instances. We need to be mindful about our spending, and for sure you don't have to change these scale to 6 instances in your own environment. 2 is exactly enough. Okay, so we still have time. We just had half an hour, so I believe we can take one more assignment for today, one more task. Let's be productive. Let's move as fast as we can. So we did auto scaling. First, any questions regarding auto scaling? Any comments? Any questions? Yes, sure.
Is there a way to name like the instances that have been spawned by the auto scaling group? Because like when we saw them, they were all named Boston, and like when we created like multiple, we used count point index, and now we don't have that counter. Is there a way to differentiate them between
No,
the different instances?
no, there is no way to differentiate, and we don't have to. Each instance is one of the kind, and they will always be identical. There is no reason to differentiate. Yes, you might connect using its own IP and it will remain unique, but the tag itself is totally not required. And you don't have to care about which like identifier you have. Today, this instance exists, tomorrow it will be terminated.
Yes, thank you.
So there is the entire like pet versus cattle approach. So when you have a pet, you take care of him or of it, of him or her. If he gets ill, you take him to the vet. You make sure the I don't know, the best toys is available for your cat or dog. You walk him and you see him as a I might say as a person, right? It has a name. You have emotional connection, and this is pet. But what does cattle mean, right? Cattle is something that people grow on the farms for food, right? And no one, unfortunately, that's very unfortunately, and I hope no one from Greenpeace is listening now. But cattle is no one give names to cattle, right? There is cow number 1, cow number 2, cow number 3, and so on, right? And it's just one of the kind, right? And same situation, same pet versus cattle approach for our infrastructure. So in case when we have a separate server, right, it's a pet, right? If we misconfigure it, we have to figure out what is wrong. We're trying to troubleshoot it, we SSH into it and try to fix it. That's not the right approach. The right approach is we are creating the user data script, which is reusable and can run like always. We are deploying standard instance using autoscaling, and does not matter if the instance for some reason stopped working, we just replace it, throw it away, and create a new one, right? We are not creating this connection between the server and the business, and this means it's not a single point of failure. Then, does it make sense? Why we don't have to have unique identifiers for instances managed by autoscaling?
It makes perfect. It makes perfect sense.
Okay, yeah. You can search more, by the way, on the internet or on YouTube for pets versus cattle, and they will give you even better explanation on this topic. Yeah.
So is this example only applies in horizontal autoscaling or also in vertical autoscaling?
I don't really understand the question.
Do we need to care about the instance when we are autoscaling vertically, like increasing the memory, increasing the storage?
Yes, in this case we have to care. In this case, it's still a pet. And vertical autoscaling is not really best approach. It's better to attempt to scale horizontally, because at least there is upper limit, right? Even when AWS is capable to provide you, I don't know, 1 terabyte of RAM, right? There are really gigantic instances out there. It's not possible to go beyond this point, right? And eventually you'll hit this higher limit. And second, it will still be a pet then if we just scale it vertically and just add more instances. And it will not be highly available then. It goes away, right? We need to have some fallback, some standby, multiple instances behind a single load balancer.
Okay, thank you.
Yes.
So can we choose the how can we increase the instances? Like for now, it's based on the requests, or I don't know if you
we can change instance type anytime we would like. We can, yeah. Obviously, 1 million of micro instances will not work at some point, and real infrastructures have bigger instance types. But like the first thing that we usually do is scaling horizontally, means adding additional instances of the existing type.
Okay, and we auto scale based on the number of requests, or what exactly?
We auto scale, and that's a good question. And there will be a separate home task that I will ask you guys to do separately. How you exactly auto scale. And usually scaling is done in a classic world by CloudWatch metric, by number of, for example, by CPU load. You read CPU load, you set the threshold. For example, if all of our instances are higher than 80% of load, then add a couple more. Or vice versa. If all of instances are below 20%, delete unneeded. That's how it's working. Okay, now for the next part. Let me go and create an S3 bucket first. We can do these manually for now. Now, what I will do is SSH to our public instance. And of course, obviously, I need to change my IP address. Sorry for that. Okay, and I will SSH to one of our private instances. For example, this one first. Doesn't matter which exactly. I just need to take its IP, and connect. So we have an instance. We have a bucket, right? Let me show it from my local CLI, right? From my local computer. So this one, I created new terminal window and it's running on my local machine. And let me change the color of this terminal so we can distinguish it. So let's say I want to list my buckets, find out which buckets do we have, right? All these three, same that we see in CLI. But if we would like to run it, the same commands from more EC2 instance. It says it's allowing us. It's saying us you need to configure your 8 credentials, right? It doesn't have credentials now. So the obvious step might be just copy your access key and secret key and attempt to paste them here, right?
Yes.
But what will happen since we have auto-scaling group now? When auto-scaling destroys this instance and creates new one.
We have to do it again. The IWS consider meaning entering over key ID and everything if you want to use the view S3.
Yes, that's exactly right. And in general, storing any access or secret key on the instance that you run in AWS is a bad practice. But there is a concept of so-called IAM role. Let me first create it manually and just to demonstrate you the idea. So in AWS, we can go to IAM. We can go to roles and let's press create role. I'll pick a policy S3 full access and create it. EC2. Okay, now what we're gonna do is change the settings of this instance in the somewhere in the over here in the security tab. Modify IAM role and attach it to it. We will need couple more minutes, maybe half a minute. And when we run AWS S3LS, pay attention. I did not paste any access key. And immediately it started to give, to interact with S3 API and return proper secret. So when you need some AWS command line or AWS API SDK to run on your instances, to authenticate it, you should not use access key and secret key. You need to create an IAM role and assign it to your instance. And by doing this, you kind of giving this relation that this instance can do any actions that's defined in the policy for this role. Does it make sense?
Can we say similar to service accounts in Kubernetes?
Yes, it is very similar to service account. In fact, when we run Kubernetes on AWS, we use combination of service accounts and IAM roles. In Kubernetes, we will say that service account will have connection to this role, and every pod that uses this service account can also have permissions of this IAM role. Any more questions? Yes.
I just want to know what really happens when we attach a role to an EC2 instance.
Excellent question. So there is internal metadata service. It can be accessed by connecting to the following IP. 1 second. Advanced instance meta. This endpoint 169.254 is not a public IP address. It is available only from within this instance, and it contains a lot of useful information. Like, for example, you can find out which AMI ID you're using, or, for example, which security groups is assigned to this instance. Also, on top of that, there is a separate IAM part that contains the no, not IAM, but somewhere over here. Let's identity. Yeah, maybe perhaps identity credentials. No, maybe profile. Let's try one more last time, and if it's not profile, then we'll leave it. We'll bring it offline. No, not profile. Okay. Anyways, so this metadata service, somewhere within these folders, AWS automatically put access key, secret key, and also a session token dedicated solely to this instance. That will work only from within this instance. And AWS API is capable of automatically detecting that this endpoint is available and extracting these credentials from metadata, from internal metadata. Okay, so then let's automate this. But first, I will remove this IAM role that we've manually attached. Or actually, we don't have to do this. We can just terminate the instance, and it will work perfectly fine. Immediately, we see that the connection closed. And once we automate this with Terraform, we'll connect to some new instance. Okay, first resource we will create is called the AWS IAM policy. It has the mandatory parameter of name. Let's call it env code and also S3 access. And also we will create a policy for it. Something like this. This JSON snippet means that we put this multi-line string into the parameter, and it will allow basically all S3 actions. Also, we need to create the resource called IAM role. So policy just a set of permissions, and role is the entity itself. Assume role policy means not permissions that are assigned to the role, but which entities can use this role. Assume means use. So in our case, it's EC2. This means EC2 instances can use it. For example, this can be some user source also can assume role. It can be another AWS account, or it can be another AWS service. For example, if we were to use Lambda, and this Lambda function, serverless function, will have to interact with AWS resources. Here, then we should have use Lambda like this to allow assigning this role to Lambda. But for our case, it's EC2. Also, we need to attach our role to our policy. So here is the role, basically this one, and here is the attachment, like a role binding. We are connecting a role to the permissions that it has. And also an instance profile. An instance profile is an intermediate resource that also works as a connection, but it in turn connects an instance to the role. And in our ATOS scaling group, what we need to do is add additional parameter, actually in our launch configuration, called IAM instance profile. And it will be a reference to our IAM role, like this one. Let's get back to our terminal, run Terraform apply. Let's try hitting yes. Yes.
So for creating a role and attaching it to a resource, we had to create multiple Terraform resources. My question is...
Sorry, could you rephrase once again?
Sorry. So to attach a role to a service, we had to create multiple resources, right?
Yes.
My question is, how can we tell which resources we need in order to obtain what we need? For instance, for the load balancers, there were a lot of other resources that we had to create.
Mm-hmm.
So if we do it from scratch and we don't know that we need, for instance, attachment groups and target groups, we won't be able to properly create a load balancer.
Yes, very, very good point. So how it usually works. So obviously, yes, what I'm showing, I've been doing it for a while, and there was a process of myself figuring it out. When you have some new service that you're not aware how to work with, you first go to AWS documentation about this service. Some tutorial published by AWS. For example, let's imagine we never created load balancers, right? So what we do, what any engineer is doing, first it goes to Google. Create a load balancer, AWS. First result in Google search is like 99% of cases, the tutorial published by Amazon Web Services themselves. Let's check what they say. And basically there is traditional wiki-driven explanation about where you should click, what you should go, and how you should register it. Right? Go to EC2, choose target groups, create target group. We already know that we need target group, right? And step by step, register target, configure listener, and so on. So first, you're trying this manually in your own lab and your own sandbox. After that, once you configured it manually, once you understand which resources you need, you go to Terraform AWS load balancer resource in Terraform documentation. And the very neat thing about Terraform documentation is that it always has examples, right? And yeah, that's just a load balancer. Do we have some more complete examples? No, unfortunately, no. Load balancer is not the best example, but they will anyways always demonstrate you some samples of how you might use it. But having understanding of these, you already better understand what you need to do here. And what we essentially doing by me showing this to you, I am first pinpointing which features of AWS worth attention, and basically we're kind of, by having this demo, skipping these two parts. But when you work yourselves, when you work alone, it's always a good idea to read these, to search and read these documentation.
Okay, thank you.
Okay, getting back to our error, it tried to destroy launch configuration, like recreate, but we have an auto-scaling group. So we will do one simple trick. Since we are not in production, we can afford this. Let's delete our auto-scaling group, run Terraform apply one more time. It will delete auto-scaling group and update our launch configuration. And after that, we will return the auto-scaling group and recreate it from the brand new config.
Should we put the IAM in level 1 as it is like the base, or
I would not put it there because it's not related to network, and we might have multiple auto-scaling group, for example. I'd rather keep it in level 2, but it's my preference. If you think level 1 is better place for it, of course you can move forward. Why not? But make sure that you'll always have to be aware of this, right? For yourself, if you make this deviation from what we are doing. And let's actually help out the scaling group to destroy our instances. Because sometimes it might like wait for it to do different drainings and close all connections. Yeah, it struggled to update its status from healthy to removing it, and without removing these instances, it's not allowing us to basically finish the terminate process. Yeah, one went away. Yeah, very good. It should be gone for now, right? Very cool. Come on, Terraform. Yeah, sometimes this happens. That's very unpleasant thing about it, like any cloud things. So sometimes provisioning or destroying or changing resources might take. For 5 minutes is not that long. Sometimes it might take like half an hour to deploy something, and you just have to sit and wait until it's done. If you're good at tasking, that's great. If you are not that good at multitasking and not able to concentrate when you have to wait for something, that's very awful, almost unbearable. But that's what we have, unfortunately. Never repeat this at home. Always make sure you know what you're doing if you want to terminate the plan before it actually finishes. Okay, very cool. Now we should have our new auto-scaling group. No, we've deleted auto-scaling group. We need to uncomment it now and run Terraform apply one more time. Okay, let's go to autoscaling. Here is our autoscaling group. Let's go to instances. And let's SSH to, for example, this one. No, first we'll check and make sure that, yeah, this IAM role exists. And it contains our S3 access policy. Okay, very cool. So now we can get back to our bastion and SSH to this instance. When we run AWS S3 LS without any credentials, it's returning the correct list of buckets. It's authorizing our API calls successfully. That's it for IAM roles. I will create a new branch. I will add everything. and create another pull request, but you don't have to sit and watch it. For now, I believe we're good. Today was very productive. We have covered 2 topics. The tasks are on the Trello board. Video will be available as usual. Thank you for watching, and talk to you this week at Thursday.
Thank you.
Thank you.
Bye.
Goodbye.